Regarding how ash composition influences the hot strength of coke, we first need to understand the composition of ash components within the coal. From this chart, we can see that ash components in coal generally do not exceed 21 elements. Among them, 8 elements are relatively important. On average, they account for over 98% of the total ash content. Therefore, our focus is to clearly research the weighting of these 8 ash components on the final result. Next, we will research them across 4 different categories. The first category is acidic metals, mainly silicon, aluminum, and titanium. Their common characteristic is high temperature resistance. For example, aluminum, even exceeding to 0 degrees Celsius, is able to maintain the stability of its state and performance. Therefore, throughout the blast furnace production process, they are beneficial for improving the coke's hot strength. The second category is alkali metal oxides, mainly potassium and sodium. They begin to decompose and react at temperatures over 300 degrees Celsius. At around 100 degrees Celsius, they are almost entirely volatilized, thereby destroying the coke pore walls. Moreover, once volatilized, they exert a strong catalytic effect and continuously accumulate, increasing their concentration inside the blast furnace. The third category is alkaline earth metals, including calcium, magnesium, barium, and strontium. Alkaline earth metals in coke usually exist in the form of oxides. Their fusion and softening temperatures are around 20 degrees Celsius. Therefore, initially, people did not believe these elements had a significant impact on hot strength. However, subsequent production practice showed that changes in these elements greatly affect hot strength. Research by scientists later found that, on one hand, alkaline earth metals act as catalysts by multiplying the reaction rate through an oxygen transfer mechanism. This has a catalytic effect. On the other hand, alkaline earth metals at high temperatures can react with the silicon and aluminum inside the blast furnace to form complex silicates with lower melting points, thereby lowering the overall ash melting point. The fourth category is iron 3 oxide. The melting point of iron 3 oxide is around 530 degrees Celsius. However, research shows that iron 3 oxide can form a new eutectic system with calcium oxide. This reaction starts at 800 to 900 degrees Celsius, thus destroying the coke pore walls and reducing the coke's hot strength. The proportions of these 4 categories vary greatly among different coals, which leads to a large difference in the hot strength of cokes with the same cold strength.